LRO is this remarkable spacecraft carrying 7 scientific instruments. It has been orbiting the Moon since June 2009, collecting many different kinds of data. This information helps NASA make better decisions about where to send robotic spacecraft and humans in the future. At the same time, it helps answer important scientific questions, not only about the Moon, but about our solar system as a whole. I'm Mark Robinson, Principal Investigator of the Lunar Reconnaissance Orbiter Camera, or LROC. So what exactly is LROC?
Angle cameras are very high resolution. They're pixels about this big, 50 centimeters. And it was designed so that you could look at a human scale on the surface to find safe and engaging landing sites. Then there's a third camera, a wide-angle camera, which is literally about this big. It maps.
They were designed so that we can examine the lunar surface at a human scale and identify safe and scientifically interesting landing sites. Then there is a third camera, the wide-angle camera. It maps the Moon at ultraviolet and visible wavelengths. Finding new impact craters is not easy, because most of them are very small. We can really identify them only when we have an earlier image of the same location and another image taken afterward. Because we have been in orbit for several years, we can now go back to images taken during the first year or two and compare them with newer images on a computer screen. If something wasn't present in the earlier image but appears in the later one, then we know that something has changed. We call these temporal pairs. We now have several thousand pairs like these. But examining every pixel in every image manually could take one person 10, 20, or even 30 years. So we began developing an algorithm, a computer program, that uses a small template to search through the before and after image pairs and automatically identify changes. So far, we have discovered hundreds of changes on the lunar surface. Many of them are so small that it is difficult to determine with certainty whether they are new primary craters or secondary craters. But we have found more than 25 craters that we can positively identify as new impact craters. You can clearly see their rims and ejecta. And we made another surprising discovery. We also found secondary craters associated with these impacts. At one point, a very bright flash was recorded by a video camera. A team at NASA's Marshall Space Flight Center recorded it, and it was the brightest impact flash they had ever observed. So it should have produced one of the largest new craters they had seen. They were very interested in having us photograph the location and find the crater. Based on the energy of the flash, they had predicted how large the crater should be. But that prediction was based on a model. So this was a great opportunity to actually calibrate their model. We took an image centered on the coordinates they provided, but we couldn't find a crater. Instead, we discovered several mysterious little spots. Something had disturbed the lunar surface, and those marks had not been present in the original image. But we didn't know what they were. So we thought, okay, perhaps their coordinates were slightly off. Their camera pixels were very large. In fact, their pixels covered an area larger than the footprint of one of our images. So I said, okay, no problem. We'll move west and start building a mosaic. The next month, we took another image and repeated the process. This time, we found even more of those spots. But in that image, we also noticed something that looked like very faint rays. And we thought, wait a minute, could these actually be rays coming from an impact crater? So we did something very simple. Then, the following month, we went back again. Remember, this was our third attempt. We positioned the camera's field of view directly over that latitude and longitude. Boom. We took another image. When the image came down, there it was. A beautiful crater about 18 meters in diameter. Then we started looking more carefully. We now had 3 images, and we were finding hundreds of these tiny spots and rays. Once we had the bigger picture, we could see that the spots were actually aligned in a specific pattern. Groups of very small pieces of ejecta had traveled 10, 20, and even 30 kilometers away from the impact site. Think about that. A crater only about 18 meters across produced effects that could be seen as far as 30,000 meters away. And that made this an incredibly exciting discovery.